Hello everyone, I'm GafTheMaster974 today, and welcome to a very different and special kind of video. I'm going to be talking about how you can create your own gaming virtual machine. Now, you might say to yourselves, but Gav, this video already exists, so why the hell are you creating it? And the fact of the matter is that there are some things that have been mentioned in a video by some ordinary gamers, which is definitely why this video exists. And there are some things that were kind of implicitly mentioned but were not actually physically stated. So the whole purpose of what I'm doing today is to actually kind of clear the air up a bit, but to also hopefully let you guys know how you can create your own gaming virtual machine if you so wish to create one. So I have a little checklist of things here that I'm going to talk about, and it's going to cover the essentials of a gaming virtual machine for you guys. So the first things, the first thing that I'm going to be covering today is the reasons why you might want to actually create a gaming virtual machine for yourselves. And honestly, I would say that a big reason is because you want to. Now, there's not necessarily any need to do so. If you can, then you should just really install Windows 10 to a separate hard drive and just, a hard drive that's disposable, that you don't really give a damn about. But if it's a hard drive you do care about and you want to partition it or whatever, then you can do whatever. But as a passion project, you might want to go ahead and create a virtual machine for gaming purposes. Another reason is because you can. I mean, if you have a high-end gaming PC, then on the balance of probability, you will be able to create a gaming virtual machine out of it. So because you can, you'll probably follow this video and end up creating a gaming virtual machine. Alternatively, you can do the Some Ordinary Gamers route and use a gaming VM to test viruses. Now, I don't know about you, but I wouldn't want to risk compromising my personal files just to play something like the PlayerUnknown's Battlegrounds ransomware, for instance. So that is a reason why you might want to, create a gaming virtual machine, is so you can test test viruses in a contained environment, but that's not always 100% safe. So do keep this in mind. It is a virtual machine. It is not 100% safe. You really have to isolate yourself from stuff like the internet and all that to really guarantee any kind of safety. So what I'll do now is talk about the prerequisites. So these are the things that I would argue are the things you absolutely need if you're going to be creating a gaming virtual machine. And if you don't have any of these, or you're not sure about it, then on the balance of probability, you're probably not going to be able to actually go ahead and create this gaming virtual machine. So I would argue right off the bat, you would need 2 graphics cards. On the balance of probability, you already do, if you have a gaming PC at least. You will have your dedicated graphics, which will be your AMD or NVIDIA graphics card, but you'll also have your processor's onboard graphics card. So technically that means you have 2 graphics cards, and that's good. You'd want to have 2 monitors, though you could also have something like one TV, like I have, with multiple HDMI input sources. So for my 4K TV here, for instance, there's 3 HDMI input sources. So you can just basically have the internal graphics, which Linux will be using, and I'll cover that later, and then dedicated graphics, which is the NVIDIA, going to another HDMI input source, whatever it is, and then that's how you would actually go onto the virtual machine without having 2 monitors. Though 2 monitors is easier because then you can monitor Linux and the virtual machine at the same time. And due to the way the virtual machine works, you'll probably want to have a second keyboard and mouse as well, because when you go into the virtual machine, it's going to lock out access to the keyboard and mouse you would be using on Linux. You could always get something like Synergy later on, but if you do want to be able to use Linux, then you want to have a second keyboard and mouse to begin with. You also want to make sure that your processor that you're using is VT-D or AMD-V compatible and capable, I guess I should say. this is basically it's the virtualization technology. So you can Google your processor, and under Intel or AMD's website, it'll have, you know, detailed information about the processor that you've actually researched, and it should say, you know, VT-D, which is Intel's virtualization, if it actually supports it. That is needed for the virtual machine. Sadly, if you don't have it, then you can't do anything with it. You want to make sure that you have a IOMMU capable graphics card or motherboard. I read this step somewhere online. Apparently you need it. I don't think there's any easy way to check if that's the case, though what I would say as well is you want to make sure that the motherboard itself is UEFI capable, and on the balance of probability, as I keep saying, if there's a mouse associated with the motherboard when you go into the BIOS settings and you can actually have a mouse and move around, then you have a UEFI capable motherboard. So, and to some extent the graphics card would also be UEFI capable, so that's something that you need. 16 gigabytes of RAM at the very least, because you want to be passing off a sizable amount of RAM to the VM. If you have a system with 8 gigabytes of RAM, then you're probably only going to be realistically able to pass on something like 6 gigabytes of RAM. That's probably not enough for gaming, especially on like brand new games. So something like 16 gigabytes of RAM, like my system has, then you can easily pass 8 gigabytes or more of memory to the virtual machine and you can game on it. And you want to have something like a 8 gigabyte flash drive, a USB flash drive. I have a 16 gigabyte flash drive here, so this is more than enough. And if you're going to go down the route of using Debian, then I think Debian actually has like this full package install. It's like an ISO file, and it's really large. It's like 8+ gigabytes or something. So if you want to go down the route of Debian, then something like a 16 gigabyte flash drive is what you'd want. Alternatively, you can use something like an 8 gigabyte flash drive, or even a 4 gigabyte flash drive if you're using something like Fedora or Arch Linux or Ubuntu, for instance. And this is so because we're going to be using Linux basically as the main operating system, and we're going to be creating a virtual machine in Linux. So Linux basically allows us to do what we need to do to create the virtual machine in the way we want to create it. And so we're going to be basically installing it natively and creating a new operating system and install it to the drive that we're going to be using. So first things first, in terms of steps of creating this gaming virtual machine, you want to download Linux. So as I have kind of said, Linux is like Windows or Mac OS. There's several different versions of it's branching out. So Linux is like the overall term for all of these different distros of Linux. So I've mentioned some already. There's Debian, Ubuntu, there's Arch Linux, Fedora, Cubes, Tails. So many different distros of Linux. Some are more, better than others for this kind of purpose. So the main ones I would argue would be something like Arch Linux, Debian, or Ubuntu. And I have tried to use Debian in the past, but the problem for me is I have wireless internet, and for some reason Debian doesn't allow you to use wireless internet. It only allows you to use Ethernet unless you have like the wireless adapter drivers or something like that. It's quite strange, but Ubuntu for me works. So in my case, I'm using Ubuntu. Regardless of what Linux operating system you use, there's something we're going to be getting later on called OVMF, and we want to make sure that OVMF is the most up to date on the version of Linux that you're using. So in the Some Ordinary Gamers case, it was Debian. In my case, I'm using Ubuntu. Now, I don't know if OVMF is the most up to date on Ubuntu, but I've tried a gaming virtual machine on Ubuntu and it works for my purposes. So I'm going to be, doing this guide as if you're using Ubuntu. It's pretty straightforward to use, I think. So go on to Google or Bing or Ask Jeeves or whatever and look up Ubuntu and download an ISO file for Ubuntu off of Ubuntu's website. Then what you want to do is get a tool called Rufus. Rufus allows you to create bootable USB mediums out of your USB flash drives, for instance. So once you have your Ubuntu ISO, you want to download something called Rufus. It's an exe file, and you can go through the whole process. It's relatively straightforward. You just select the Ubuntu ISO, you make sure that your flash drive's inserted into your computer beforehand, obviously, and then go through the process of creating a bootable USB. So a couple of things that's swing to mind is you want to make sure it's set to UEFI or GPT. So UEFI is because we have a gaming PC. That's the more up-to-date version of BIOS. BIOS is for more older systems, and GPT is the general partitioning table, I think, and that replaces the master boot record. So again, that's just so you can use it on your gaming PC. In my case, you have to make sure it's a UEFI flash drive, otherwise it's not going to load it up properly. So you can go through that and create a USB installer of the Linux distro of your choice. In my case, it was Ubuntu. So once you have done this, you want to go onto your gaming PC. If you're not on it already, make sure you get 2 keys nailed down. You want to know your BIOS key and your boot menu. So usually these are a myriad of different buttons. Sometimes it's escape or delete or any of the function buttons like F1 to F11 or F12. So in my case, it's delete to get into the BIOS. That's what we're going to do first. So as soon as the PC comes up and it shows the splash screen of HP or Dell or Gigabyte in my case, as soon as it comes up, you just want to mash that key, like, Advanced Warfare, where you mash F to pay respects. That's a Some Ordinary Gamers joke, stealing it from myself. And you should go into your BIOS settings. Again, if you have a mouse and you can move around, then you are good to go, because that means you're UEFI capable. And you want to look for some settings. So you want to look for your VT-D or AMD-V setting and turn it on. You want to find your internal graphics, which is the processor's internal graphics, and you want to set it to on. And you also want to change the output from PCI, which is basically the dedicated graphics, to whatever the alternative is, which replaces it to the internal graphics. So what we'll be doing is using the internal graphics to output to our monitor or TV in my case, and that's what we're going to be installing Linux to. And then the graphics card, which isn't going to be used by Linux, but it's going to be used by the gaming virtual machine, is actually going to be outputted to a second monitor or HDMI source. So we basically don't want to use the graphics cards, the dedicated graphics cards, in Linux at all. So we want to make sure we're using the other graphics card for Linux. So once you have all of those things taken care of, and it could be difficult because everyone's motherboard's different, so this step could be the most complicated to follow. You just need to find, your processor's virtualization, the internal graphics or onboard graphics, and then change from PCI to whatever option it is, whatever option that's not PCI. And then once you've done that, you want to make sure that you insert your flash drive into your PC, and then you want to restart, and then look for the key that's the boot menu. In my case, I think it's F11, so just spam that as soon as the PC boots up. And what you want to do is access the UEFI USB that you have inserted. That's going to be the Linux installer. Just install it like you normally would. It's going to be installing Ubuntu onto your system, or Debian or Fedora or Arch Linux, whatever version of Linux that you have. And then once that's all installed, get a feel for how it works. It's different than Windows and probably Mac OS, so it will take some time to get used to. But first things first, if you just want to get straight into the meat of things, then what we want to do is access a terminal. This is the equivalent to the command prompt in Windows. This is like the backbone of how you use Linux, and that is pretty much the top and bottom of it. If you're using Linux, then there's a very high probability that you're using the terminal a lot. It's really useful, and it allows us to use certain tools and input certain commands that makes it really helpful to create some pretty nice things, such as a gaming virtual machine, for instance. So the first thing you want to do is type in sudo nano /etc/default/grub and then hit enter. You'll be asked to put in a password. It's actually your account password. This is how you use superuser in Ubuntu. In Debian, I believe you just type in su for superuser, then input your password, and there's actually like the account password and the root password, and you want to set those to the same thing during the installation process. But yeah, it's essentially going to be your account password in Ubuntu to be able to use superuser commands. So you have to use sudo every time you want to do that. And what we're doing is using something called Nano, which is a way you can view and edit in the terminal. And we're looking into the grub file, which is actually the bootloader of Linux. And what we want to do is go down to where it says grub _cmd line _linux _default. And we want to type in there somewhere, preferably after all the stuff that's already in there, i915.alpha _support 1, nuvo.modeset equals 0, and intel _iommu equals on. So basically what this does is, I believe i915.alpha _supports basically turns on support if you need to get your Linux kernel patched if your processor doesn't have the iommu stuff we'll be talking about later. Not 100% sure if that's needed, but just type it in to be on the safe side. Not 100% sure, as I said, so if anyone knows why you would actually need to put that in, then please let me know in the comments below, and it'll help me and everybody else out in terms of this gaming VM stuff. Nuvo.modeset equals 0 is actually needed, so one of the steps later on when you look into the kernel drivers in use for all of our devices, we make sure that Nuvo is not going to actually take hold of something that we don't want it to. We want something else to take hold of it. So we set that essentially to be turned off to begin with, so Nuvo is not using anything. And of course the key step here is the intel _iommu equals on, which is your processor iommu. It's going to tell us about our groups later on. So we need to turn it on now so we can access the groups in a later step. So press Ctrl X to close, press Y to save, and then after this just type in sudo update-grub to update the bootloader. It should take really short amount of time, seconds, and then once that's done, restart the system. So what this does is enabled iommu, so we can actually look into iommu groups and see if our graphics card is in its own space. And if it is, then we're good. If it's not, then you're screwed. Basically, that's just the top and bottom of it. So to see if this is the case, once Linux is restarted and you've logged in, go to another terminal and type in lspci-nn, Norman if you will, just double N. And what this will do is list all of your PCI hardware devices inside your game PC that's in use. And it will list all of the hardware ID numbers. There's usually something like 01:00.0 and some 8-digit number separated by a colon, so it's 4:4 for your graphics card. So you want to see which graphics card you have, and it should be the graphics card and the audio controller for it. So in my case, I have a NVIDIA GTX 1080, so it should say this is the GTX 1080 and this is the audio controller for it. There's the hardware IDs on the left hand side and also on the right after it. You want to keep note of these, so put them in a notepad or something, or write them on a sticky note, whatever you want to do to keep a track of those numbers. And what you want to do after this is actually go and type in after this find /sys/kernel/iommu_groups/ and then after that -type L. And when you type this in, it will list all of your iommu groups in the kernel. And what you want to make sure is that the hardware IDs that you wrote down earlier is in its own folder. So in my case, it's in folder number 1, and there's only 3 things in it, and that is the graphics card, the audio controller for the graphics card, and the PCI link for the graphics card. As long as those 3 things are the only things in that folder specifically, then you're good. If there's graphics card stuff in other folders, or there's other stuff in the graphics card folder, then you're probably not going to be able to continue, because that's a fault with the kernel of Linux, and that's where the ACS patch, the access control system, a patch for that, a patch for Linux's kernel, may come in, which may have something to do with the i915 support as stated earlier, which is why you might need to turn it on to allow the kernel to be patched properly to allow you to do this. But if it's a brand new, Debian or Ubuntu install, then there really shouldn't be any problems. And if your gaming PC is capable, then you should be getting the same results as me. So if that's the case, then you're all good. That is actually the scary step of this entire video out of the way. So once that is done, you want to go ahead and type in sudo apt install ovmf, and after that do sudo apt install virt manager, which is virt and then a hyphen manager. What this does is it installs and downloads all of the virtual machine stuff that we're going to be needing. So ovmf, that's just stuff for the virtual machine, and of course the virtual machine manager that we'll be using. And it looked like some creepy, crazy stuff. Just let it do what it needs to do, and once that's all done and dusted and installed, you want to do sudo nano /etc/default/grub. We're accessing the grub bootloader again, and under the grub _cmd line _linux _defaults, which is where we added intel _iommu earlier, we're going to actually type in after that vfio-pci.ids equals, and then it's going to be the hardware IDs, which is the 4 numbers, then the colon, then the other 4 numbers for the graphics card and the audio controller, and you want to separate them by a comma. So it'll be 4 numbers, colon, 4 numbers, comma, 4 numbers, colon, 4 numbers. It might not be numbers, it might be letters as well, but you get what I'm saying. That's how you would do it. And once you have that, again, Control X to exit, Y to save it, and then do sudo update-grub to update the bootloader. And then we're not going to restart it just yet, because there's one more thing we need to do. And so to do this, what we want to do is do sudo nano /etc/modules. And what we're going to do here is enable the VFIO modules to be launched at boot time, to basically allow VFIO-PCI in this case to grab the graphics card before Linux actually can do anything with it. So what we want to do is in this modules file that we have in our terminal, we just want to type in VFIO, then enter VFIO_PCI, enter again, VFIO_IOMMU_type1, and VFIO_VIRQFO, and save it. Do the Control X and Y and all that to save it, and then once we've done this, we can restart. So what this will do is, because we've already installed our virtual machine stuff, it's going to allow this VFIO to be enabled on boot and allow it to grab hold of the graphics card so Linux doesn't have access to it. And this is where nouveau.modeset=0 actually comes into play, because usually nouveau is the thing that actually grabs the graphics card on boot up. So we don't want that to happen. We want VFIO to take hold of it, so then we can use it in the virtual machine later. So to ensure this has worked, there's a couple of things you can do. You can actually go under like change backgrounds, for instance, or look into this. Look under the display settings, and it should say there's something like 2 monitors or something, or 2 outputs. If you have, the graphics card, the internal, and then the dedicated graphics going to the same TV, or to do 2 different monitors. Normally it would say, yeah, you got, a dual monitor setup. But once you do the step, it'll only identify one monitor, which is what you want. But to be 100% sure it works, go to the terminal again and do lspci-k. And what this does is it will list all the PCI devices again, but it will tell you which kernel drivers are using them. And if you scroll down to where the graphics card is and the graphics card audio controller, then it should say that VFIO-PCI is actually using the graphics card, which is exactly what we want. It means it's worked. So this basically, as I've already mentioned already, means that Linux cannot use our dedicated graphics card. It's locked out. So this means we can use 100% of our dedicated graphics on our virtual machine, which is pretty good. So at this stage, we are in a position to create the virtual machine. Now there's a couple things we need to download off the internet, one of which is going to be linked in the description of this video. You can also Google search for it if you want to. It's actually the VirtIO-Win ISO file, which contains all the drivers for VirtIO for many different operating systems for Windows. So you want to download the ISO file, and one thing to make note of, because we're using Linux, I think the default option is to actually mount the file. Don't mount it, save it. You want to actually have a hard copy of this file on your actual computer. So save VirtIO-Win ISO onto your computer, and also get the most recent version of Windows 10 from Microsoft's website, and that should give you a ISO file as well, and just save that locally as well. So once those have downloaded, what you want to do now is open up the virtual machine manager, and now we're in a position to actually set up the virtual machine to use. So first step is just press forward, because it's already selected to use local media on our computer. So just go ahead, go to step 2. And what we'll do now is actually browse for the media, which is the Windows 10 ISO that we downloaded. We'll actually save the default memory CPU settings, because we'll be changing them later on anyway. So we don't need to, change them now. We want to create a 40 gigabyte hard disk drive image, which is going to be what Windows is installed to. You don't want to create something smaller than that, otherwise Windows will have problems and it'll say no, you can't actually install because you don't have enough hard drive space. And you don't want to go ahead and create a drive that's really large, because then if you're going to do one of the steps later on, which is to clone the VM in case anything happens, then you'll be cloning a really large hard drive, which is something that's going to take way longer. And one of the steps I'll mention later on, which is optional if you really want to, is if you use a 40 gigabyte drive, then you can actually create another hard drive image with a lot of size on it, and then just attach it to the VM later on and put all of your stuff onto it. So then if the VM fails, you use the clone of the VM you created and just attach the hard drive image, and then you can go from there. But leave it as a 40 gigabyte hard drive image for now. After this, what I want to do is change the name of the VM to Win. Nice and easy. This is so we can, call on it later without doing anything too intense. And if don't click anything else, make sure you check the checkbox for customize configuration before install. We're going to be changing a lot of things, so make sure you check that and then carry on forwards. So first things first, in overview, we're going to be changing from BIOS to UEFI, and the chipset we want to change it to Q35. Now it might give you an error. I don't think it did in my case. This is just needed for the VM to work, so just change it. So from BIOS to UEFI and the chipset to Q35. Under CPU, we want to check the checkbox that we copy the host CPU configuration. In my case, I have an i7-7700 processor. I don't know what kind of processor that is. It might be a Kaby Lake, I think. But under the list of different configurations, that's not there. So I've seen as well that you can type in host-pass-through, and that allows for the best quote-unquote performance. Though just click copy host CPU configuration, don't deal with it unless you know that the type of processor you have is there listed. But you know, if it's not, then just click the checkbox and then don't worry about it, because it'll just copy the CPU configuration from the processor that you already have in your system. And what we want to do at this point is actually research the processor information. So in my case, I have an i7-7700 processor. I can just type that into Google, go under Intel's ARC, which is their database of all the processors, and look into the actual nitty-gritty details. This is where you can see if VT-D is actually something that your processor has, but it also tells you about its core structure. And one thing that we need right now is something called topology, and I don't know anything about this sort of stuff, so this is like double hearsay because I'm basing this off of what some ordinary gamer says, and even he says that what his explanation was very simplified and probably not 100% true. So essentially, for our settings, for my settings at least, because I have an i7-7700 processor, sockets is going to be 1 because we only have one processor. If there's a motherboard out there with more than 2 processors at any one time, then let me know. I could really do with something like that. And 2 different kinds of processors as well. That would be really interesting, but that's more custom build territory, I'm sure. But sockets is usually 1 because you only have one processor, right? Because I have an i7-7700, it's a quad core system, so cores is going to be 4. But threads in this case is only 2 because there's actually a total of 8 threads. And threads can be real or virtual. So the way I would envisage it is you have a certain number of cores and they are physical, which means they really exist. They are actually here in your processor. But then there's 2 threads associated with the one core, one of which is real, which you can, I guess, argue it does actually exist, but then there's the virtual one which doesn't exist, but the processor interprets it as if it does exist. It's kind of a awkward explanation, but because you have a real and a virtual thread for every core, that's why the threads is 2, and then we have 4 cores. So you'd think you put 8 in the number of threads because that's how many total threads there are, but it's actually 2 because there's, you know, for every core there's 1 real and 1 virtual for core, you know, thread basically. It's kind of hand wavy, I know, but you know, if it's some kind of bizarre processor where that's not really the case, then it's kind of why you would have to research this sort of stuff so you know what you're doing. But usually threads should be 2, and cores is the amount of cores that your system has. So in my case, I have a 4-core system. Some ordinary gamers has an 8700K, that's a 6-core system. I would argue that the stuff like virtualization, like virtual machines, or video rendering for instance, it would benefit to have more cores. But for gaming, you'd want fewer cores that run at a faster speed, whereas some of the higher core, you know, systems you see tend to run at slower speeds. But anyway, that's besides the point. Maybe that's not true, I don't know. But that's probably the most tricky stage to comprehend. So just Google search your processor info and it should come up nice and easy for you, if you have a nice processor, that is. I don't know about any bizarre processors that exist where threads is going to be like 3 or something, but what this will do is actually change the CPU allocation to the VM. So this will make it so by following these steps, your CPU allocation to the VM is only going to be 1. And when you actually get into the VM, you'll see performance wise it runs like absolute ass. So what you want to do is actually change the CPU allocation to the maximum allocation, in which in my case it's 8 because you have 4 cores, 2 threads, and therefore it accumulates to 8 CPUs in total. So we want to have 8 CPUs in the virtual machine, because we want to make it look like in the virtual machine that we have 100% of the processor active. So we have our 8 CPUs like a i7-7700 would in native Windows 10. So you're trying to create a virtual machine that doesn't know it's a virtual machine. That's kind of what we're going for here. Otherwise, what's the point in doing stuff? So that is what we would do there. That's a really complex step, and I really don't know if that's a good explanation of it. But once you have comprehended that and got past it, you want to go to memory and just allocate a certain amount of memory. In my case, I chose to give 12 gigabytes of RAM to the VM. You can give 8 gigabytes or 16 gigabytes if you have, you know, a lot of RAM. Then allocate what you would see is suitable. I would recommend anywhere between something like 6 and 16 gigabytes of RAM, but it all depends on how much memory you actually have. So if you have 8 gigabytes of RAM, you probably want to choose 6. If you're like me, you have 16 gigabytes, you can go between 8 and 12, something like that. And obviously if you have 32 gigabytes or 64 gigabytes, then you can go even higher than that. So once that's done, save it, go on to the disk that we've created and change the disk bus to VirtIO. And we also want to go down into the advanced options or performance options, whatever it's called, and change the cache mode to write back. And make sure that the storage format is QCOW2. This is just what we need to do to make sure that the disk image we created actually works as intended in the virtual machine, because we're using VirtIO. It's supposedly faster, so that's good for us. We like fast stuff. So once we have done this, there's a bunch of stuff that we can delete. So delete the CD-ROM drive, the tablet, display spice, console, channel spice, video QXL, USB redirectors. Just get rid of all of it. And this should leave us with the USB controller, I think it is. And at this stage, just change it to USB 3. That means it's the most fast USB type that we have right now. So that's very helpful for what we want. Otherwise, USB 2 is pretty slow, supposedly. So change it to USB 3. Then go to the NIC, and we want to change the device model to VirtIO. And now what we're going to do is actually go to add hardware, and we're going to add a CD-ROM drive. And this is going to be the Windows 10 ISO file. So this is a CD-ROM that's going to have the Windows 10 ISO, which is what we'll be booting into first to install Windows. And we also want to create another CD-ROM drive for the VirtIO drivers that we downloaded as well. That other ISO file, which probably was the first thing I told you to download. And now we get to do the pretty awesome cool part of this video, which is to actually go to add hardware, go to PCI host device, and attach the graphics card and the graphics card audio controller that we separated earlier. So this means we have 100% graphics card pass through to the VM, so the VM uses all of our graphics cards, which is pretty damn awesome. And at this stage, make sure you have your second keyboard and mouse connected, because once we start up the virtual machine, the keyboard and mouse that you allocate to the virtual machine is going to lose access in Linux. So if you still want to use Linux, which you probably would want to do to, you know, check on the VM health and, you know, close the VM if you need to, then it will be beneficial to have the second keyboard and mouse. So go under add hardware, USB host device, and add a keyboard and mouse. And once we have done with this, we can go to boot options. We want to check the little checkbox that says enable boot menu. Then we want to select the Windows 10 CD drive, which is probably CD drive 1 first. So make sure that's on top. And then also select the hard drive that we created, the 40 gigabyte drive. And make sure that's selected and is second in line. So once we boot into the VM, we'll be booting into the Windows 10 install first, then into the hard drive second. So that means we can actually get into installing Windows. Otherwise it just boots to a blank drive and we're not going to have anything on it, so it's just not going to do anything. And so once we've done with this, we can click begin installation, and hopefully what you should see on your second monitor or your alternative HDMI source on your TV, in my case, is that it should go into this like splash screen for custom firmware, whatever. It would prompt you to press a key to boot into the Windows 10 installer, So you can do that, and once you do it, you should see the Windows 10 installer. Once you've seen that, that's it, that's good. That means it's working perfectly fine. But there's one more thing we need to do, which is something that I need to do because I have a NVIDIA graphics card. As far as I know, NVIDIA doesn't like the idea of you being able to install your graphics card drivers in a virtual machine. I think I've had it happen to me before. It looks like it does it, but then it gives you an error at the end, and then you can't update your graphics properly. So at this stage, if you have an NVIDIA graphics card where you want to force close the VM, even if you have an AMD graphics card, I don't know if you can do this in terms of like getting your graphics card drivers and all that. You might want to follow this step as well. All we're doing at this stage is attempting to hide the fact that we have a hypervisor from the virtual machine, so it allows us to get our NVIDIA graphics card drivers. Excuse me. So after you've force closed the VM, we want to go into our terminal and type in sudo virsh edit win. That's VIRSH for virsh, and type in 1 type in 1 if it asks you for an editor to use, which is just Nano, which we've been using. So once that is loaded up, it should look like a whole bunch of text, all properties of the VM that we have. At the very top, under domain, but before it actually ends, you want to type in xmlns :qemu equals, and then in apostrophes or inverted commas, whatever you want to call them, put in https://libvirt libvirt.org/schemas/domain/qemu/1.0. What this does is it enables QEMU to be used inside of this virtual machine, which is what we'll be using to allow commands at the very end to be allowed to actually, perform properly, basically. So right at the very end of this file, before domain finishes but after devices finishes, just type in what is shown in the video. It should be something like QEMU :command line, and then in one line we want value equals -CPU, and after that we want value equals host, HV_time, KVM equals off, and HV_vendor_ID equals null. And you want to do it in the way I do it, because that's the way that in the file, stuff starts and then stuff ends, basically. And what we're doing here is essentially allocating the CPU and also trying to hide the fact that we have a hypervisor and we're turning KVM off. So basically the virtual machine is supposed to know it's not in a virtual machine. And the thing is, if you go into Task Manager, so you can save this basically, right? At this stage, save it, and it should work perfectly fine for you. It should say XML config edit, it's the XML configuration's been edited. You can reboot Linux if you want to. You can boot into the virtual machine at this point, go through the Windows install, just like a regular Windows install. I'll get to the point I was trying to make later on, but if you try to go through the Windows 10 installer, then you'll get to a point where you have to install it to a hard drive, and it won't show you any drives because we need to actually install the drivers to be able to use virt.io. So once you get to that stage, just go to load driver, click on browse. You should be able to go into the virt.io drivers CD drive, go down to VIO store, then under W10 and AMD64 is the drivers that you'll need to be able to view the hard drives. So allow that to, get through it, basically, to use the drivers to use the hard drive. Select the drive, the 40GB drive, and just let Windows install from there. Then once it's all done and dusted and you're actually on Windows 10, then you want to go into your device manager, and underneath the Ethernet controller, which should be showing something that's not there, you want to right click it and select update driver. You want to press browse locally, and under the virt.io drivers CD drive again, go under NetKVM, W10 and AMD64. This will actually use the internet drivers so you can access the internet. And so at that stage, you'll have access to the internet, and you can use Windows Update to download all Windows updates and Windows Defender updates, and most importantly, your graphics cards drivers. And it might take a really long time to do, but once it's done it, then you'll have all of the things that you need. It might ask you to restart Windows, so you can do that, and there you go from there. At this stage, you can clone the VM and then create that hard drive, that 200, 300, 400 gigabyte hard drive that all of your games and stuff can be downloaded to, and you can go from there. Basically, it's as simple as that. And then if the VM fails or you download a virus and it fucks up your system, you can just delete the original, use the clone, but make sure you actually clone the clone before you use the original clone, if that makes sense. And you can just keep doing that. I mean, you have to make sure you attach the hard drive you created with all your games on it to still be able to use all your games, and you don't lose all your files, which is pretty cool if you ask me. That's how I would go about doing it. So the point I was going to, remember when I said just a few moments ago there was a point and I was going to, save it till later. This is the point I'm going to talk about, is that you can go into Task Manager and it will show the correct processor, it will show the correct sockets and cores and threads, but it will still say it's actually a virtual machine, even though we've done steps to make sure that the virtual machine doesn't know it's a virtual machine. I think from Some Ordinary Gamers' PlayerUnknown's Battlegrounds ransomware guide, it was actually supposed to show up with something like not applicable. So it's like, are you in a virtual machine? We don't know. But in my case, it says, yes, you definitely are. So I don't know if that's anything to do with the OVMF being up to date, or the step where we edit the virtual machine using edit win, and there's something in there that I haven't done properly. I don't know what the situation is, but as far as I know, my Windows 10 gaming VM knows it's a VM, and that's probably the worst thing about this whole thing. But the weird thing is the graphics card drivers actually install properly. So even though the virtual machine knows it's a virtual machine, NVIDIA doesn't know it's a virtual machine, so you can download all your drivers and access all your files perfectly fine, which is pretty interesting actually. And I don't know why. I don't know how to actually deal with that situation. So if anyone does know, please leave it in the comments below. I'll be very grateful to hear what you have to say if you know how to fix this issue. I don't, but it kind of works, so it is what it is at the end of the day. So at this stage, you can download Steam or Origin or Uplay or whatever you use to play your games. Download all your games and go from there. So at this point, what I have to say as well is, just keep in mind, you can only attach 4 USB devices to your VM at any one time. You already have your keyboard and mouse attached, so you can only attach another 2 items to your gaming PC. So just keep that in mind as well, unless you have a USB device that somehow goes into more USB devices to connect to it. I don't know if that works. It might be able to, and if that's the case, then you can use more than 4 USB devices basically. But in my case, I don't have anything like that, so I can only use 4 USB devices at any one time for my gaming VM, just so you know. I mean, I try to do videos in a gaming VM, and with a keyboard and mouse already taken, I have like a microphone and a webcam and a headset I want to use. Can't use all 3 of those at once, so you have to make sacrifices or compromises, or just buy something where you can have more USB devices available to you. But now we get to talk about the games. Yeah, the games that I've actually played in this VM. I would say overall it's actually pretty decent. It's close to native performance in some cases, though in other cases there's definitely some noticeable issues and definitely reduced performance compared to natively using Windows 10. So the games I played, I actually ended up playing Half-Life 2, Portal, Borderlands, the remastering of Borderlands, Bioshock Remastered, Borderlands 2, Scavenger SV4, Doom from 2016, Space Engineers, Distance, and even Ballistic NG. And I would say I'm pretty happy with the performance, though as I said, there are some problems with it, and it is definitely down to the fact that it's due to being run in a virtual machine where you need the processor power especially. But because I have a quad core system, you don't have the necessary cores to do virtualization, so that's where it kind of would cause some performance drops. So I would imagine if I had something like an 8700K processor, an i7 8700K with 6 cores, then I probably would get way better performance than I would with my 7700 processor that I have right now. Though generally I would still say it is pretty good. Now the final thing I have to say, please try to avoid multiplayer games, because there's the possibility that the games you'll play will ban you or give you a VAC ban or whatever it is for using a virtual machine, because the game might identify the fact that you have a virtual machine and it might identify you as a cheater. And the last thing you want to have happen to you is be identified as a cheater. So don't even risk it. Don't risk multiplayer games, but any single player based games you can play, or just single player experiences. If there's multiplayer attached to it, just don't touch it. But if there's single player stuff, then definitely deal with it. And you should be good. It should be perfectly fine, and you should be able to game and deal with max settings pretty easily. I mean, I have my i7 7700 processor, my GTX 1080 with 8GB of memory on it, 16GB of RAM. I think I allocated 12GB in this virtual machine, so I was well away with my games. To be honest, I can play games with max settings even from today's day and age. Space Engineers is a bit of an off one because that's still like a work in progress, and that's does cause some noticeable frame rate drops, I would say. Same with Scavenger SV4. I think it's because it's a indie based game that's kind of unoptimized. That causes frame rate drops as well. So I don't know what kind of system you'd need to play those kind of games at the highest settings at consistently good frame rates. Maybe a far better system than I ever will have in my life. So with all this being said and done, I am 85000G. That's the gaming virtual machine video. I hope you've enjoyed it. If you haven't enjoyed it, then I can understand why. It's a very nerdy technical video. I've gone over a lot of things. I've talked for over 50 minutes straight now. That's why I might have fucked up in places, especially towards the end. My throat is actually on fire right now, so I just want to end this. But if you have any problems, let me know. If you found it helpful, let me know. Let me know about your performance at the end of the day. And hopefully you actually can learn something from this. See, this is more of a response to the Some Ordinary Games video for not including certain things. This is essentially the same guide. And you might be wondering, well, why the hell am I doing it? Because, to be quite honest with you, I needed to. My gaming PC, the hard drive that came with it, was actually having problems. It was actually having problems to the point where I could not use Windows 10 natively. It would blue screen on me all the time. The only solution I had was to use something like Linux that I knew would work consistently, and use a Windows 10 virtual machine to actually use Windows on my gaming PC. And that would have no problems whatsoever. But even doing that, Linux would use FSCK to say, oh, there's corrupt files, and it would delete stuff. And even the creation of this video, there were files that were being deleted. So unfortunately for me, that was just really annoying me. But luckily I did actually get a hold of the people that I got my PC from. They replaced the hard drive for me. It's actually just sitting over here, not in my PC. I'm going to have to see if it works. But I'm using a SSD that my brother got me, to be honest. And I'm using Windows 10. I've had very few issues. And I'm actually really enjoying it. And I should be able to get this video rendered okay with no issues. It's just going to take a shit ton of time, let me tell you. Got so many different sources and videos to use. And I don't know how ambitious I'm going to be with it. But let's just say If it comes out in June, then that's going to be awesome. So with all that being said, ladies and gentlemen, thank you for watching. I am going to have to rest my voice for quite a long time before I speak again. I hope you found this video enjoyable. Please let me know what you think. If you want more videos like this, which are more lengthy but more edited, let me know. And I'll see you for the next video, whatever I decide to do. Even though my monetization has been taken away from me, that's not going to stop me doing videos, because I never received a single paycheck doing YouTube, and I probably never will. But it's probably for the best that way. That way you get legitimate content from legitimate people. Anyway, that's it. I'm out. Okay, goodbye. Have a great day or night or whatever it is. See you later. Fuck, my voice fucking kills me now. Damn it.